Once you have your functions written, then you can go ahead and start writing your script files, which your script files are all very similar. Start with the single case and then copy and paste that in to your analyze material, analyze geometry, and then you'll do your last one. So for a single case, you're going to go ahead and prompt the user for options. So prompt the user, enter in a cross section. Here's your menu, that's what's printed out, and they will enter in a number, 1, 2, 3, 4, or 5, because that's what your function needs. Remember, your function needs a 1, a 2, a 3, or 4, or 5. Keep in mind, there may or may not be a space right here. And then you're going to write a user validation loop. So a loop to validate that the user entered in a specific number. So you're going to essentially say, while the number is not valid, reprompt user. That's essentially what your while loop looks like. While the user number is not valid, so while they didn't enter in a 1, a 2, a 3, or a 4, reprompt the user. So keep track of how many times you're prompting the user. If you get to 3 times, so if they don't get it after 3 times, then you're going to go ahead and break it and call the error function. So the error function works just like disp. Instead of just displaying it to the screen, though, it's also going to stop your program and print it out in red. But error works just like disp. So you would say anything you would say with disp, you would just type error instead. So display, error, etc. Instead of just display, you type error. So you're going to have 3 user validation loops, 1 for the cross-section, 1 for the orientation, and 1 for the material. Keep in mind your numbers change. 1 and 2 for the orientation, and then 1 through 7 for the material. Once you have all of that information prompted in from the user, you're going to use an area of 0.01 meters cubed and a length of 3 meters. So that would be your A and L values in your equations, or A/area, whatever it's called. And then L is your length in your equations. Then you're going to call your functions. So call geometry and call material. Geometry returns A, B, and I. Material returns rho, E, and sigma. Keep in mind, it needs to be the appropriate units, appropriate values. And then this is given a safety factor SF equals 4 and a gravity constant G and M equals 101. Calculate the recommended maximum load using equations 3 through 6. This is what equations 3 through 6 looks like. They're not in the order that you need them to be in. Okay? They're presented like this because it fits the narrative, but it's not the order in which you're going to use. So SF equals 4. So essentially, you can use SF down here. Given that, you can go ahead and calculate sigma max. So you're first going to calculate sigma max. Once you have sigma max, you can go ahead and plug that into this equation and use this one to solve for F. Capital F. That is your maximum recommended load. Your maximum recommended load. Keep in mind we have a safety factor S equals 4, which means that your maximum recommended load is 4 times less than the breaking point, than where your beam is going to fail. Once you solve for your maximum recommended load, you can go ahead and plug that in to find your F vector. So plug in F here, plug in delta X from this calculation. So first you calculate sigma max, then you solve for F, then you can go ahead and find your F. So F is just your point load represented as a vector. So if you think about the load across the beam, what it's going to be at this value, this value, this value, this value, this value, all these values, essentially it's 0, 0, 0 here, and then right in the middle is where you have this massive load that's represented there. That's all that this little f is. It's the force at all of the points along our beam. Once you have that f, then you can go ahead and call your deformation function. Your deformation function takes in all those inputs, all these inputs, Okay, we said G is going to be 9.81. Mu is this equation right here. It's buried in there. It's your area times your density. It's defined as the weight. It essentially represents the weight of the beam. So it's the weight of the material per unit length. So if we take just 1 unit of it, so 1 meter, whatever that unit is, it's the weight of that. Okay. So that's mu. E, I, dx, and f, those all more or less make sense with our other variables. Once you have those, you can call your deformation. So that'll give you z. And once you have z, you can go ahead and essentially do the outputs. So here you're going to save data to a file. Save data to a file. Here you're going to print out data to the command window. And then here you're going to plot your deformation. That's the general flow for all of your script files. You're going to take some input from the user, you're going to do your calculations, and you're gonna save some data, print out the data, and plot the data. Your second script file is analyze material. You're essentially doing the single case for all of the materials. So given a single cross-section, given a single orientation, now calculate in a loop the data for each material. So for each material, which there's 7 of them, you're going to call your geometry function, call your material function, calculate what your F is, calculate your deformation. You're going to save some data to a file. You're going to print some data out to the command window, and you're going to plot some data. Same thing for analyze geometry. For analyze geometry, same idea, except this one you're going to prompt the user for material, and then you're going to go through all the geometries. So this is a nested loop. You're going to have a loop that goes through each orientation and a loop that goes through each cross-section. For a vertical orientation, you're going to go through all the cross-sections. For a horizontal orientation, you're going to go through all the cross-sections. You're going to call your functions, calculate your force, call your deformation. Save some data to a file. Print some data to the command window. And plot some data. Once you have all of your script files done, you will have one final script file that's going to ask the user to more or less figure out if they want to analyze geometry, analyze material, or analyze a single case. Same thing, you're using a user validation loop, but then you just have a basic branching statement. If it's 1, go ahead and call the analyze geometry script. To call a script, it's just like you call your test files. You just literally type in the name of the script. If it's 2, you're going to call the analyze material script. If it's 3, you're going to call the single case script. That'll give you 4 different script files. It's a lot of copying and pasting, but make sure you keep track of what each one is supposed to do and compare it to what your output's supposed to be.